So focusing kind of just on this last piece here, I used our f of x equals mx plus b. So the mx plus b is our linear equation piece. We call this f of x. We read it as f of x. And what this is saying is that we're just putting in x as our input. As you'll see in the next bullet point, that f of x is just another name for y. That's all f of x does. It just kind of takes the place of the y. It serves the same purpose. To have a place for our outputs to go. And I think this last bullet point kind of sums it all up. If f is a function, we can use different letters for functions. Most of the time with word problems, like if you're talking about height, your function could be called h. If you're talking about growth, your function could be called g. If f is a function and x is our input, then f of x represents the output that corresponds to the input. So the x, the y that comes out after we plug in our x. We're going to draw a little picture to get this all straight. We're going to go back to the idea of kind of our two ovals. So draw two ovals on your page. We'll label our ovals. We'll say our x values, and then we'll say our y values. And let's just say, let's pick three numbers. We'll just do the number 1, 2, and 3. I'm going to put three numbers over here. Let's go 3, 4, and 5. So like I said before, we have these arrows that are being mapped. Let's say 1 goes to 3, 2 goes to 4, 3 goes to 5. But there's something happening in the middle. All right, this is where we use our f of x function. Think of it, you can put this into the machine does something, it spits something new out. What this machine is doing, it's taking each of our input values and it's adding 2 to it. It's saying, all right, it's our x value plus 2, we get 3. Our x value plus 2, we get 4. Our x value plus 3, we get 5. So our f of x function would be our x values, all of our x values, plus 2. This is what function notation does, all right? Really simply, it takes all of our x values. We perform whatever our function tells us to do. It spits out a y value. Right? The notation part looks tricky, but it's really not. We're going to say we're evaluating these functions. Evaluate means get out a number. We're given the function f of x is equal to negative x minus 1. We're finding f of 1. So f parentheses 1, notice how it was up above, it was f parentheses x. That means this 1 is taking place of our x, and this is going to be our input value. That's what we're plugging in for the function. So we want to kind of think of our next step. We're going to plug in for x. All right, that's our step that we're going to do. So I'm going to rewrite f of x as is, because that's what I'm trying to find. All right, this is my unknown. That's my output. And now, instead of writing an x in there, I'm going to replace it with a positive 1. So what I have here is I have a minus symbol in the front. So I'm going to put that minus symbol in my equation. I'm plugging in a 1 for x. I'll do that in red so we can see. Whenever you plug something in, it's good to put it in parentheses. And they're writing minus 1, just because it's still minus 1 here. So now we're just going to go through and we're going to simplify this till it gets to be one number. So this is -1 minus 1. Which is then equal to -2. So we could say f of x is equal to -2. What that means is when our input is positive 1, our output value is -2. This is something you've actually been doing a long time in math. Plugging a number in, getting a different number out. Now we just have this notation, which is helping us with ordering where things are going. Okay. So looking at example B, like I said, we can have different letters. This is the function h. So h of x is equal to 2x plus 3. We're going to find what our output is when our input is 0. So again, think. You're replacing the x value with a 0. So we would keep h of x is equal to, it's 2 times x, so that's 2 times 0 plus 3. And now we evaluate this. So we just have to make sure we're following order of operations. Got to multiply first, and then we can add. So 2 times 0 is 0. We have 0 plus 3, which is going to give us positive 3. So our answer would be h of x is equal to 3. Sometimes you'll see people write this as, instead of having their x here, you'll write it as h of 0 is equal to 3. This is also a good way to write it. What this just shows is your x value, your input, and your output at the same time. Input. And then you get what your output was. So I'm going to go through, and maybe for the next few examples, I'm going to write my final answer like this. I'm going to say practice doing this way. Everything else will come easier if you practice this way. Right? So, given g of x is equal to -4x minus 5, we're going to find g of -4. Another strategy you can use, if you remember, all right, the number that's inside of the parentheses is my input value, and it goes in for x. Draw an arrow for what it's going in for. Another good thing to do. And then rewrite. g of x is equal to -4, and then in parentheses, -4. So that's what we're substituting in for x. Then we have -5. I simplify. -4 times -4 is +16. I have 16 minus 5. That would be equal to 11. So I could say my input when g is -4, my output is 11. Right. Again, you don't have to do anything with this g of x on this side and like try to subtract the g of x from both sides or anything. You're just plugging it in for the x value of your equation, not for the notation piece. We'll do one more example like this and then a few other where you just use a graph and it's pretty straightforward. So we would say f of x is equal to -3 times our x value, which is +4, -5. So -3 times +4 is -12. We have -12 minus 5. So you have a negative. We're subtracting off of it, so we should get a smaller negative number. 12 minus 5 is 17, so we have -17. Excuse me. So when our input is 4, our output is -17. Plugging a number in, getting a number out. Any questions on kind of those first four? No? All right. So last piece, when we're talking about how can we use this function notation and figure out values based on a graph, we want to find the value of f of 5. So remember, this is f of an x value. So 5 is our x value, and x's are always our inputs. Right? So I'm going to draw an arrow and say this is our input. We're wondering what our output is. All right, that's all we're doing today, solving for outputs. On a coordinate plane, I'm given essentially a list of x values. Remember, a graph is just a set of inputs and outputs. So I'm looking for if my x value is 5 on my coordinate plane, I'm right here. I'm looking, all right, where on my graph does 5 intersect with? Well, if we look down, it goes down 2 boxes, and I'll draw a little point there. This is the point 5, -2. Our graph is saying when we input 5 into this function, we get out a -2. So we would write our answer as f of 5 is equal to -2. -2 is our output. The only output that matches with our input. So again, you're looking for where the x value that you're given and your graph intersect. So negative 4. Negative 4 is right here. I'm just going to look. Sometimes I do it with a little dashed line. Make sure I'm hitting the right spot. My point is right there. Remember, points always go x then y. So I'm looking at the point negative 4, comma, positive 2. So my input is negative 4, and my output is positive 2. So to write my answer, I could say f of negative 4 is equal to 2. I have my input, and I also have my output.